Okay. Thank you. Hope you had good lunch. And at the same time, I hope that you won't be sleepy. So, and this presentation won't be boring, so you fall asleep. So, my name is Tomasz Cholewa, and today I'm going to talk about Kubernetes and OpenShift. So, let me introduce myself. I'm a DevOps enthusiast, that's why I'm here. I'm also infrastructure as code practitioner. I love automation and I love playing with code, provisioning infrastructure. I'm a passionate learner. I like to learn, I like to apply my knowledge and also test it, so I have some certificates. Currently I work as a lead cloud architect at Mindbox, where me and my colleagues we are creating modern environments based on containers, orchestrators, of course, and cloud. So, first question, has anybody of you heard of container? No. That's actually a good answer, because it's 2017. So you should already be familiar with this awesome buzzword, another buzzword. And in case you've been gone for 3 years, like doing some interesting stuff, or like going to Bieszczady and cutting yourself from latest technology, here's a quick recap. So some say that containers are just lightweight virtualization. That's not true. Because basically containers are just processes running in isolated environment. And some people say that you can also run containers in Windows, but basically Docker has been Docker used Linux kernel features, and before Docker there was some many other technologies like LXC, of course. But basically, it's all about Linux kernel features. And today, not only Docker is available for you to run your containers, there are also many other projects like Rocket, like Cryo. So, container revolution that was initially started by Docker, it's not the first revolution that we've seen. At least, maybe I'm that old, but when I started working with, for example, virtualization, it was supposed to be this awesome technology that will solve your problems, that will make everything okay. Well, it turned out that it's not. We have still some basic problems that aren't solved. And yeah, and some people say that, you know what, just keep containers, just go ahead with serverless. My opinion is that you should have a middle step between serverless and virtualization, because containers are something between. It's not as awesome as serverless technology, but it can offer much more. And basically, also, containers are somehow associated strongly with cloud technology. And serverless, basically, it's all about cloud. It's running inside cloud. And there are some surveys that say that there are some companies brave enough to run containers in production, not in some test dev environment that we used to play, but in real production. So this is a short list of companies that decided to move on with the newest technology. But I know that in a couple of months there will be many, many more. The list will be longer, it will be growing. But honestly, guys, have you asked yourself a question, can you run modern environment without containers? I think yes, because regardless of the drawbacks of virtualization, it is still awesome technology. It's relatively cheap. You can buy virtual machines on your cloud provider. It's easy. It has really great isolation. So if you only need isolation, virtual machines will do it much, much better. And this huge ecosystem that that was created for many years, it is reliable. It can offer you much, in some cases, a much better solution for your problems. And actually, containers aren't magic pill that will solve your problems. It's just a technology, let's be honest. And not everything can be containerized. So there are some workloads that cannot be containerized, and even if you can put it into container, you won't get much more benefit than just using virtual machines. And yeah, so you can run. So yeah, so I've heard you can run virtual machine containers using Windows, but don't. So containers offer you many, many interesting things like single format, no more depths, no more RPMs, no more jars, just a single format for putting your application with everything that is needed to run it. Express setup, I love the feature. That's why I started my work with Docker, where I could just launch set of application with a single command using Docker Compose. It's just excellent. It brings you innovation. You can learn, you can bring your innovation to your company and experiment. That's the DevOps way, I guess. And how about security? For me, containers brings a lot more security than virtual machines, because I'm sure that many of you heard of SL Linux. So who has actually written a SL Linux policy? Yay, brave ones. Excellent. So, but many guys just use this magical command set and force 0 and go ahead. Even if the default policy can bring you more security and prevent you from some security bugs as well. So containers also require you, or at least encourage you, to use stateless applications, and maybe in microservices architecture. And yeah, so you can run them on Windows or using Windows containers, but Linux containers are just the best, and they have every piece of software assumes, almost every piece of software assumes that you will be running Linux. So, and the most important thing for me is cloud native mindset. So you need to switch your mindset from this legacy approach to the cloud native. Even if you're not going to use containers or just keep them and use serverless, you need to have this cloud native mindset. Also, containers forbid you to do some things, or at least discourage, like tampering with running containers. Of course you can do it using Docker exec, but it's not the way that they were designed to do. So putting everything inside containers, like Chris from yesterday keynote mentioned, so putting everything inside huge containers, it's not the best way to go. Assuming that it will always work on the same node, because virtual machines usually stayed on the same physical machines. I know that you could actually migrate them, but they stayed on the same machine. And actually doing anything with hardware, it's not the way that containers, containers discourage you to work directly with hardware. And finally, container orchestrators, they bring more features than bare containers, like easy scalability, like putting your container and scale it horizontally, like real portability using the common format, like enhanced security. So on top of security features that Docker brings, there are many more that are brought by container orchestrators, and I'll be talking about it later. And consistency. So no more configuration drift between environments. And the same question emerges. So can you use containers without container orchestration engines? Yes, you can. You can find some valid reasons. Like, for example, you want to use it as a better packaging system, and that's all you need. That's fine. And your application doesn't scale, and you just don't need, because container orchestrators are quite complex piece of software. So you don't need this complexity for you to run containers. And maybe you're building something better. You just haven't published it yet on GitHub, so we're waiting. But if you do have such reasons, stick with good old virtual machines. So Kubernetes is a project initiated by Google, as you may heard, and they claim that it's a better version of their own internal orchestrator engine, which is Borg. So they published a white paper claiming that many things are done better in Kubernetes than they are in their original Borg system. So it's also part of Cloud Native Computing Foundation, alongside with, for example, Prometheus, excellent monitoring tool. Sorry. And it has become the standard among container orchestration engines. Let's face it, there is Docker Swarm, but even Docker Enterprise Edition introduced support for Kubernetes. There is Nomad, one of my favorite ones, and but still Kubernetes is the leader among container orchestrator engines. Its increasing adoptions probably will help you to convince many other companies to also adopt Kubernetes for their containers. OpenShift is also a project, but it is initiated by Red Hat, and open source edition of OpenShift, it's called OpenShift Origin, but Red Hat is a commercial company and also offers subscriptions that you pay for support and security related updates, and not only. So we have many different products, including the ones that will allow you to run it on the cloud. So current release of OpenShift includes Kubernetes, because OpenShift includes all the Kubernetes features. And the drawback is, so we have Kubernetes in version 1.8, but the newest version available in OpenShift is 1.6. So if you need the latest features, OpenShift will not bring you to you. So before version 3, there was some version 2, and maybe some of you has had opportunity to work with it. It's a totally different product or project. And funny thing is that OpenShift 3.0 was released before version 1.0 of Kubernetes. So guys from Red Hat were so fascinated about Kubernetes that they decided to change all the technology within OpenShift, and they released it even before final release of Kubernetes. And Red Hat is also one of the main contributors of Kubernetes project. But actually, in short, Kubernetes is a big project. It's a general purpose, and we have many different products based on Kubernetes. And one of those products is OpenShift. And OpenShift is a rather platform for these containerized apps. So let's see how these two projects differ. Let's start with installation and operation. So on Kubernetes, you have many different ways you can install your cloud, like, for example, using KOps, one of my favorite tools. And on OpenShift, you have code, Ansible code for installation. And I must tell you this because it's not the best code I've ever seen. Let me repeat it. It's not the best code I've ever seen, but it works. It's very complex, and besides installation, it offers upgrading, maintaining, and so on. And we have also single node projects like Minikube or Minishift. If you want to experiment with Kubernetes or OpenShift, just grab the project, and in a couple of minutes you will have one node installation running on your laptop using virtualization of your choice. Also, both projects come with dashboards like this one from Kubernetes. It's installed as an add-on, and OpenShift also offers something similar, but it is built in. It's a part of the project, not a separate project like on Kubernetes, and it's got this fancy login window that you won't get in Kubernetes. When it comes to platforms, you can install Kubernetes almost everywhere, even on Raspberry, but when playing with or using OpenShift, you are constrained to those systems like RHEL, CentOS, Fedora. And of course, Kubernetes is getting more and more popular. So Google, as a founder of the project, has its own hosted version, and also recently Azure also come up with their own version. Or at least I wait for the same version on AWS. Let's wait for the rain event. Additional things that you may need for your Kubernetes, like logging and monitoring. It's delivered in rather do-it-yourself manner. The same goes with OpenShift, but OpenShift brings it with this Ansible code that I've mentioned. And it also got a different monitoring system based on JVM project called Optical, and it can also have a container registry which is integrated within a project, not like an add-on, like in Kubernetes. Networking, quite complex thing, and Kubernetes allows you to use many different SDN as plugins, and so does OpenShift. And OpenShift additionally has two SDNs as delivered also as plugins. But the most important difference is that on OpenShift you have dedicated project for traffic management. Like on Kubernetes you have ingress, and routes is a different way of, but very similar, but implemented in a different way, way before ingress was introduced in Kubernetes. When it comes to security, Kubernetes uses Airbag for its access control, and here's the list of predefined roles you can use in Kubernetes after installation. Yeah, it's empty. So here's the list of predefined roles that you may find on OpenShift. we have many different roles, including cluster administration, single admin for a single project, and so on. You have capabilities or possibility to create them on your own on Kubernetes, but it's the same as with a Linux policy. Another great security feature of Kubernetes and OpenShift is post-security policy, which allows you to restrict whether your containers, for example, can launch as root user, and as we know, it's not the best way to use containers. And also, there are many different things, but for example, one of the important that you can forbid container to mount volume from the host that it's running on. And again, here comes the list of these rules. And on OpenShift, you have predefined and quite well described list of security rules that you may apply to your projects or containers. So default policy for Kubernetes is quite open, while after installation on OpenShift, you won't be able to launch. So you won't be able to launch root containers and many more things. So this is by default. So you won't need to do anything to increase your security. When it comes to application deployment, things are very similar on both projects. On Kubernetes, we have Helm. This is a different project, and OpenShift has included their own version of templating. Both are based on YAML, so they are easy to understand and write. Additionally, replica sets, the deployment object, and so on, these are very similar, but OpenShift adds more functionality using deployment config, which I will mention later, custom strategy, and A/B testing, which is possible thanks to this different implementation based on route. Also, you can use OpenShift to build containers natively using dedicated objects. When it comes to dev and ops collaboration, so my impression is that tools may help you, but in 2007 it looks like this, and I've seen I've seen companies that in 2017 it looks like this. So the main thing is that we need to understand is we live in an app-centric world. We have apps everywhere. They will be soon in our dishwashers. Hopefully they are not already. And this is all because of the business requirements. So business wants to use applications to provide new features to gain some business value. And developers' role is to provide these applications, while operators, administrators, or rather, I prefer to call them SREs, their job is to provide environments for these apps. But the common goal for both of these silos, for these roles, is to make those applications work reliably, efficiently, and in a secure way. So let's see how Kubernetes and OpenShift may help you in accomplishing this goal. Let's start with a simple but very common scenario when we have application which is slow. And what do you do in your legacy approach when you don't use Kubernetes and this cloud-native mindset? You execute some commands, like this one, probably. And maybe you even reboot, or just, or even not, when the application is running again. So you're happy, your boss is happy, business is happy, you're going for a beer. But it's all about dirty tricks and make it work and forget. Even some finger pointing, because it's dev, they didn't deliver proper applications. In container approach, well, you use built-in metrics. You provide, at least you are encouraged to provide application metrics. Of course, you could do this in your legacy approach, but this time it is much simpler. And of course, you can scale your application easily. And the most important thing, you cannot perform quick fixes. You just need to provide a new container image. And with auto-scaling, there are different ways that you can provide metrics on which you auto-scale. So Pod provides metrics to the database, regardless if it's Prometheus, Hocular, and anything else. And a special object inside Kubernetes perform checks whether these metrics exceed threshold. And it performs scaling out operation, so increasing number of pods that can process requests of your users. Currently you can use custom metrics in beta in Kubernetes, but in OpenShift you are still limited to CPU metrics only. Another scenario is when your application crashed again, like third time this week or third time this hour. So the approach is very similar. You perform SSH, you kill the Java processes, and so on. So very similar. In container approach, or using Kubernetes, you can do nothing, because it has HA built in, I would say, because you can use this prod, which will periodically check whether your pod, your container with application is running properly, whether it's HTTP check or some executing process inside. You need to use central logging, because otherwise you will lose all your logs. You can use log files inside containers, but it's pointless. And you can use built-in feature of Kubernetes, so rollbacks. You can roll back to a previous version very easily. And once again, do not repeat yourself, just fix once and deploy your new improved version. Even if you started microservices architecture, deploying your microservices applications, you may encounter with many connections between services running to deliver your value, to deliver your application. So I've seen many things, and I've seen, and this is actually interesting topic, because developers try to do things without ops, and that's okay, but they go the easiest path, and the easiest path for maintaining communication is to use IP addresses. I don't know, because like DNS was invented like 30 years ago. I know it's hard, but yeah, I've seen many things, many etc host entries, and this is not the way to go. Of course, there are some service registries that you can use to register your applications, and magically they will find themselves. So in container approach, we have abstraction layer called service. So it hides pods delivering your application behind this abstraction layer, and this abstraction layer allows you to use DNS names. DNS names for when you want to access your application. So you don't need to even provide your DNS server. You can use built-in and use references in your main DNS server. And for external access, you use this ingress or cloud load balancers to access your services. This is OpenShift and also on. I'm sorry. This is on Kubernetes, but as well on OpenShift. And additionally, if you want to communicate inside your project or namespace or a cluster, you also use service-to-service communications rather than pod-to-pod, because you're not sure how many pods are there to process your request. And additionally, when it comes to external access, OpenShift, you can use ingress, but OpenShift has this router which enables you to use A/B testing. This is something that cannot be easily done on Kubernetes, and this feature is built in this router, which is based on HA proxy. And additionally, if your company has load balancers from F5, you can use native integration. So replace your HA proxy software solution with F5 solution. So another scenario is when you want to store your data. So legacy approach looks like this one. So why it's so long and why it's so slow? Well, you didn't mention you need something faster. I have only this one, yeah, for example. And it ends up like this. You know, just developers tend to put your application anywhere because they want to have their app running and to be awesome, I guess. And probably it's all backed up, like everything. So in a container approach using Kubernetes, you have another abstraction layer, but this time it is even better. So by using plugins, like for NFS, iSCSI, and so on, you hide the storage layer, and you provide only objects inside Kubernetes that use particular storage, a piece of storage, like NFS export for like slow and test dev environments, and the same code with only a minor change you can use, for example, super fast storage like EBS, SSD. So this is part of portability by using abstraction layers. Additionally, even better solution is to use dynamic storage, which allows you to Kubernetes to outsource provisioning of your data volumes to Kubernetes. So for example, if you use even GlusterFS or cloud storage, Kubernetes will provision the storage for you and for your developers, of course. Security. Heartbleed, I'm pretty sure you've heard of it. So what happens if you encounter another Heartbleed type security issue? Probably nothing bad. So this is standard situation, and you're performing more commands, more SSH, standard, I guess, standard approach. On the other hand, when using containers, You can easily update your image, because remember, you can, but you're discouraged to do so. You need to provide a new image. So you're providing it, and on OpenShift, there's another object called image stream, which hides complexity, hides sources of your images. I will talk about it later also. And which is even more important, it can trigger deployment config objects that a new image has arrived. A new image that change only this minor thing, like fixing some library, which application, which was needed by application. And it can trigger automatically. It can trigger redeploy of the whole application on different environments. And this is also very important because these two objects are available only on OpenShift, and only on OpenShift you have a possibility to use hooks, like for example pre-hook, which will be executed once before whole application will be deployed. Like not a single pod, but before the whole process. Example usage is, for example, updating your SQL schema. That's not easy when you're doing it on a pure Kubernetes. What happens, and it's very common scenario, when your application is provided by external vendor, or you have many external teams committing to your code or their own code. So this is maybe the simple solution when it comes to deployment. Maybe you already have some sophisticated deployment process, but like SCP, like maybe even using Ansible to relaunch your application servers. So, but there are some issues with that. So I'm not sure how many testing environments you have, but unknown quality is a really kind of issue, and instructions, if there are any. So what happens when you use Kubernetes? Well, OpenShift has this really awesome feature that allow you to create whole set of objects using provided Docker image. So you don't need to provide YAML configuration for deployment, for pod, for service. It will create it for you. And also, this is interesting, it will also build a container for you if you provide a Jenkins file. So by using source code, it will auto-detect language that is used by your application, and it will use some predefined container, like with Ruby environment and so on, and will deploy it on a dedicated project, because you have unlimited, well, you have number of projects are only limited by your imagination and also some resources. And finally, another thing with security is, how do you know if your application is secure enough for a public release? Typical scenario, yeah. So if the friction arises, there's always a man who comes and resolves the conflict. And better approach, I guess, is to have nice continuous deployment pipeline. And in this pipeline, you can perform security scanning. I know that we've been talking about, today we've heard approach when you include security in deployment process. That's where OpenShift with ManageEQ, this is also open source project, can scan your containers, and if any bug is found, it will prevent this container to be used in deployment process. Another thing with container images is image policy. So image policy can prevent your developers, or can prevent deployment of containers coming from unknown source. So as I mentioned, image stream is a virtual object which can refer many different sources of containers, like Docker Hub, or external or internal registry, and image. Can you hear me? Oh, okay. And image policy, you create a policy which allows only a subset of container images to be allowed for deployment on production. That's something you won't get on Kubernetes. Of course, you can create your own mechanism, but this is a built-in feature of OpenShift. And one last thing is that you have this pipeline things included in OpenShift, and using Jenkins and on-demand slaves. It's all built in. This is a screenshot that I've made. It's not from internet. So I've seen it working, and it's really awesome. You can also use Jenkins directly, but this is something that is built in. So let me do a quick summary. So there are 5 things you need to know leaving my presentation. At least I want you to remember them. You can live without container. Just if you have automated environments working all the time, it's fine. You can use containers without orchestrators engines, but it's pointless. And finally, Kubernetes has won this war. So look no further. If you have containers, just take a look at Kubernetes. If you need more security built in or better deployment, try OpenShift. It's open source. And finally, if you choose cloud, container, or serverless, you need to also create a cloud native mindset. That's all. Thank you.